Thank you. Yeah, so my name is not Røde, like in Matador. My name is Frank Lorentzen from Danish Amhub. We have been working with Adifab and Lasse for, I don't know, ages, but me specifically for the last 2 and 3 years. I'll just try here in 10 minutes just to really unfold kind of the area of additive manufacturing and what we are working on and with. But before, I'll just show you an image that I asked Lasse to paste in because I think it's really a cool image, and it tells a lot. It tells you a lot about our country. This is from Parken this Saturday, and it's Minds of 99 playing for 50,000 Danes. So I don't know if you were part of that audience. I am a fan myself. I was not able to go, but I'm a huge fan of Minds of 99. And I won't get into a whole Corona discussion today, but I just think that let's just conclude that we made it through all right in Denmark. We made it through actually quite fantastic. And what is the reason for that? Some of it is maybe, how our government and how our authorities reacted. But I think most of it is actually trust. It's the trust we Danes have in each other, in the authorities, and in our country. Now that is really difficult to measure, so I don't bring any data. That there is a lot of trust working across hierarchies in the production side. So when you get out to the machine, you can, the CEO, the owner, the guy there who doesn't have an education, can stand there and talk about ideas and trust each other that they're doing it for the main purpose of doing a positive impact. And I have been working in a lot of countries, and I won't bore you with that, but it's a whole other ball game in China. It's a whole other ball game in Great Britain, in Germany, and even in Sweden. You do this really differently. We have a really open, honest production floor where we can share ideas. And of course, we have a manufacturer of a system that allows us to stay in that discussion for a longer time. And that is Adifab. So we are doing everything we can to support Adifab, obviously, but also this notion of hybrid production, the freeform injection molding system, because I think it's a really cool Danish idea. I really like it because it gives us the strength of trust for a longer time in our innovation and development process. And I really think that maybe Adifab could be the next Danfoss or Grundfos or Novo Nordisk. And maybe we could actually show the world how to design, develop, and produce the green products of the future. But anyway, when we look at additive manufacturing, this part of an airplane is typically what you would look at. It's the design is everything, so it's done with generative design. They looked at a form of mushroom, here Physarum, which if you use the computer and you use generative design and you put in kind of your preconditions, the computer will tell you how to design it, and it will look at how nature would design it. So it's pretty awesome. This door is twice as hard and strong, and it's twice as light. So it saves 465,000 tons of CO2 each year because the airplane industry is a really bad guy. So if we do a little bit of change, we do a lot of change. This here is Kevin Singer in the States. He has built a car with only additive manufacturing. My old Renault out there on the parking spot is probably made of 3,500 parts. This car is made of 80. I'm not bringing, kind of future scenarios. I used to be a consultant, so I'm done with that. This is actually happening today. This car is driving around in the States right now. This partition is being built inside Airbus airplanes right now. And this one, you can actually walk today in Amsterdam. It's a bridge printed in steel. Again, it just shows us what the manufacturing industry is capable of and what the technology in itself can do if we use it the right way. Now, you can produce in 3 ways. Lasse would argue 4, but let's just say that there are 3. You can form stuff, typically with an injection molder. That is the way we have done since the Bronze Age. You can form pretty much everything. This is something we know we are very good at this. Or you can cut something free. Here's the milling, or the CNC milling is really the stellar process within that. Or we can print stuff. The fundamentals around this are very, very old. This one down here is only 40 years old. So there's a lot of potential within this process still. And I really hope that Danish industry will look at the potential within that process. And that's why Danish Amhub is here. We're trying to do everything we can to ensure that all the producers, not only the big ones like Danfoss and Lego, but all the producers, and there are many thousands, there are actually 15,000 small and medium-sized producers in Denmark, that they can get to work with this process. Manufacturing and sustainability is a whole issue for itself. I won't get into the details, but if you look at each year, there are 51 billion tons of CO2 that are emitted by human beings. 51 billion tons of CO2, and they are divided like this. 27% is how we produce energy, 7% is how we cool or heat our buildings, 19% is how we grow plants or animals, 16% is transportation, and you guessed it, 31% is production. Specifically, how we produce steel, cement, and plastics. And what is the issue with these processes? The issue is that when we create, for instance, cement, we use a lot of fossil fuels to create the heat that we need for that material to be made. And then first, we start the manufacturing process. And then first, we start the transportation of it. And that fundamentally has to change. So how can we change that? That is exactly what we need to work on. If we look at, on one side, the different manufacturing techniques, and on the other side, the different materials, it will tell you that there are differences. There are different products that we can make, for instance, within concrete, within steel, and within plastics. Now, we use this. If you're in Grundfos or in Lego or wherever, you would use the technology and the tool that will give you the best advantage. Okay? So, some of the products will still be made with injection molding, and that is fine. But we need to put in place the different techniques so that we save material, we save transportation, we save CO2 in general, and we create the green products of the future. And I really think that right now, Denmark has the opportunity to get the world champions within that field. So to be the world champions within that field, we need a lot more data. We need to be sure how to choose the different techniques within our production system. And we just did a small thing, really. We asked Deloitte and Brian, who's here today also, to help us out with this. And we calculated a life cycle assessment of the Freeform Injection Molding platform together with Lasse and also Peter Bay and a company also involved in this. So I won't get into the details of that. I'll just tell you that if you have ideas, if you want to participate within this movement that we're trying to do, please reach out, because it is really difficult if you stand in a production line in Jylland and your boss is saying you need to do more sustainable production. It's really difficult to understand where to look, how to begin, what are the facts here. And we have to start by that. We have to start really giving the data to the people that choose what to do out there in the manufacturing system. Thank you very much.
My name is Thomas Trostrup, and I have the privilege of being the managing director of the Danish Plastics Association. So in this presentation, I will do a little bit, you could say, overall presentation about the plastics industry, it will be my focus area. That's what I know about. I won't get too much into detail about the technical details because I'm way out of my league when I look at the audience here and Lasse and his great house here in production site. So I'll just have a small presentation about Danish Plastics Federation for those who doesn't know us, and then trying to have some cases in a historical perspective from an association point of view, and then from our industry and our companies. First of all, that's why I'm not going into technical stuff. I can't figure this out. The Danish Plastics Federation. We are an industry organization, and right now we are about 275 members. We are representing pretty much the whole value chain. So we have the suppliers, the raw material suppliers, the tool makers, the machinery suppliers. We have the converters, the producers, and also the recyclers. And it's quite a privilege to have that broad piece of the value chain, or pretty much have the value chain in the membership. Because when you talk about the problems and the challenges we have in the plastics industry and in society, it's very good to have a 360-degree view on the problems. We know that we don't have all of the value chain within our membership. We also have our customers and suppliers and other parts of the society, and we are quite keen on inviting them into the work. I'll get back to that. Of course, we have well-known brands. We just mentioned Lego, Grundfos, Færk, etc. But 70% of our membership companies are small and medium-sized enterprises, and that's the primary focus of our services. So that is where we do most of our work. The big companies do most of the jobs themselves. There's around 27,000 employees in the Danish plastics industry, which means that we're 10% of the manufacturing industry in Denmark. And that's enough for us to be sitting around the table when you are negotiating new legislation, new standardization, and other guidelines within the business. We're part of the DI family, which means that we are having a lot of close cooperation with the Confederation of the Danish Industries, but we are an independent organization and we are entitled to our own opinions. We have the privilege only focusing on the plastics industry. So that's quite good for us. And we have a very strong international focus. The Danish Plastics Federation, of course, it's Denmark, that's in focus. But since our products are moving across borders, since the issues, the challenges, problems that we're trying to solve is international problems, we have a lot of cooperation and a lot of work outside of Denmark as well. The vision that we have in our strategy is built upon that we as an industry are inventive, skillful, and flexible, and at the same time have a huge focus on sustainability, environmental issues, and on resource. It's a strategy that most and foremost are focused on the green transition and circular economy, which is very important preconditions for reaching the goal of a very large CO2 reduction that we're facing as a society. But it also builds upon that we as an association, as an industry, are very trustworthy in the way that we are doing business. It's not good enough that we're only speaking about and having good ideas. We have to implement it. We have to take actions. We have to walk the talk. And as Frank said, there's a lot of good examples of that. And I think actually this conference today is a very good example of that, being able to showcase the good examples, the innovation in Denmark, because innovation is key. The Danish, not only the Danish industry, but throughout industry, innovation is a buzzword. We hear it everywhere, but it's not a new word. In Denmark, there's a lot of cases on how we've been innovative for many years. This picture is from our current communication campaign. It shows a picture of a woman with ostomy Plastic is also of life quality, but it didn't just happen by itself. Actually, the Ostomy Bag was an idea that came from a Danish nurse, Elise Sørensen, back in 1954. They had ostomy bags before that, but as we know it today, it was based on her experience. She had a younger sister who unfortunately had cancer and needed an ostomy bag. And as it was quite often in that time, it was a lot of social issues around having an ostomy bag, and there was leakage problems and many other problems. So she had an idea about making it a single-use bag with an adhesive that stuck to the skin. In 1954, it was patented and put into production by a company called Coloplast. I think we all know it. So a small idea getting into, the hands of skillful people, a company with capacity, and all of a sudden we have a game changer. We have a very well-known toy, the Lego blocks. They are very simple when you look at it from the beginning, but they're a highly innovative product. It's an idea that inspired from England, and it's been produced since 1949. In the beginning, the blocks were, you could stick them together, but being able to have a toy that's turned from generation to generation, you needed to look both on the material, but also the way that the blocks stick together to make sure that you have not only a sustainable toy, but also a toy that was compatible with new blocks and other things that came from Lego. So the block, as we know it, is from 1958, around that. If you have a 2x4, just a fun fact, if a 2x4 Lego blocks, which is the most common one, and you have 8 of them, you can shape them in 8,274,000,000,000 different shapes. 8 blocks, which is, well, blows my mind. And in 2015, of course, Lego took over the position as the world's most known brand from Ferrari. This is the Windmill. We often speak about windmills in Denmark. Paul Lacour was the first one. He was a Danish physicist, but he was the first one to actually trying to make electrical power out of the windmill. He got a lot of attention, and he was also the first to research, to create a research and development station that was funded by public funds. He started this in the late 1800s, and today we are seeing LM Wind Power creating the world's largest windmill wing. So there's a lot of good innovation in Denmark. And as I said, as the plastics industry, there's a lot of opportunity within the material. And I will just rest my voice for 1 minute. Just a small movie from our communication campaign saying that you can use whatever material you want. Use plastic if it makes good sense. Use another material if that is the most or the best choice. We are in our strategy also focusing on a topic called Denmark as a pioneering nation for the plastics industry of the future, which I think fits very well with today's headline for the conference, Sustainable Development. As an association, we are trying to facilitate networks where we put companies, universities, organizations, and find solutions to the problems. And luckily, we have quite good success with that. If we look at the Danish society as such, we are doing quite well. As an industry, as a society, we are imposed a number of frameworks and conditions that make us accustomed to have to think in quality, in flexibility, in efficiency, and also be very innovative when we are going to compete with other countries that may have lower salary, lower energy cost, or other fixed expenses from running their businesses. So we are accustomed, it's tradition to thinking outside the box, not only when it comes to the products, but also to running a responsible or sustainable business. We have to make sure that we are looking at our energy consumption as a factory, on efficient machineries, looking at the materials, good handling of chemistry, making sure that not only our raw material, but also designing our product so it doesn't end up in nature or other places. We look throughout the whole value chain, making sure when we're thinking in product design, we're also thinking on the society afterwards and the waste collection structure that we need to take it back into our industry to go full circle. And that's something that we are having a few examples of from the industry. We have a design guide that's had a lot of attention on the future packaging. Originally, it was more or less EU that was setting new goals for how much recycled material that was going to be, or recycling that was going to be in the different national states. We could, of course, lean back and wait for the politicians to figure out by themselves how do we achieve these goals. We didn't have the nerves to do that, so we sat down and say, if we are going to have a way of effect or position ourselves, we need to make a guideline. It turned out to be a design guide or a dialogue tool. We brought together the whole value chain, not just within our members, but also politicians, NGOs, retailers, big brand owners, speaking to them about if you are going to make the best possible packaging in the future, what does it look like? And what things should you take into consideration? And we ended up with the design guide, which both is mentioned and some of the input from the Danish Plastics Action Plan, but also right now being discussed around in Europe for seeing how to get common guidelines throughout Europe on how to design packaging. It's not only our products, it's also how we run business, as I mentioned. And just to mention, we just finished a 5-year project about energy savings in the Danish plastics industry. We had 23 companies going together with universities, with students, with good advisors, trying to figure out how do we have the most energy savings. So there was 292 different projects within this. There was a 4.7 turn back time, 4.7 years of average payback time. Sorry, thank you. And they spent around 99 million kroners in investments. It meant that in that 5-year period, we saved 25,000 megawatt hours every year and 5,500 tons of CO2 every year. And that's just the 23 companies in the project. Now, they are mentioned, some of them as cases in here, but what we're doing right now is, of course, sharing that experience, trying to get other companies into to also going forward with their looking at their energy consumption. Education is a very big part of this. It's not only about designing, it's also knowing the possibilities within the plastics. So together with Ove Vestergaard Larsen, a big recycler in Denmark, University of Aalborg, and the association, we ended up creating the Circular Academy for Plastic Recycling teaching basics about plastics and recycling to companies, to municipalities who wanted to learn more about recycling. How do we get more recycled material into our current products? How do we, design our products to make sure that they're capable of reuse or recycling afterwards? So that was a little bit about what we're doing as an industry, but also when we look at our members, they have some good cases. So in preparation for this presentation, I went on LinkedIn and all the social media to look at the news stream and try to figure out where does the different companies position themselves. We have a company, Letbæk, for example, at the Danish West Coast. They just a few years ago completely changed their whole business model. They were going for circular thinking in every possible way in their company. So it's waste management, it's rethinking design, it's produce, reproduce, and sustainable solutions. One of the products that they have a big success with is the outer core, a sustainable solution for installing windows. It may not be something that most of us think about, but when installing windows in a large building, you have a framing, traditionally it may be wood with the PU foam to insulate and to make sure it sticks. The problem with that is when you are trying to take down the building and reuse the materials, it's pretty much impossible. But making this from plastic in a way that you can disassemble it, you can not only reuse it, but you can also send it back to Letbæk Plast, who recycle it and then make a new product out of it. So it's both reuse and recycle and take back systems in one, which is some of the things that we are seeing throughout our industry. Coming here today, I thought it was only polite to mention Adifab, and I won't go into too much detail because Les and all of you probably knows it very well. But as we learned earlier today, you're here at Adifab supplying production equipment for groundbreaking injection mold shapes that makes product development and injection molding very flexible and at very low cost. So all of a sudden it's now possible to 3D print molds for injection molding with a very high precision. And well, as you mentioned, give the product designer access to many more materials than you would have else in the 3D printing. My last example will be Sable. It's one of the main focuses is recycling, is also to maintain quality in recycling. Sable is a couple of students. First, we met them competing in our plastic engineering day. We had a competition. They developed this plastic sorting machine that integrates the recycling and circular economy directly into the production facilities, so that you can take your production waste and put it into the machine, and you can avoid wasting valuable resources and valuable materials, and also make sure that you have a very high quality and purity of your recycled material. My last slide. Cooperation in the value chain. The green transition and sustainable development is a huge focus area, as I mentioned. From the plastics industry, we know that not only the products are one of the most important materials in the green transition, but it's also the way that our companies are working together with the whole value chain to innovate. We really need to do that to reach the target set for us, 70% by 2030 here in Denmark of CO2 reduction. Also, the IPCC UN released a climate report saying that we need to make sure that our emissions should be half of what it is now if we want to reach the target set in the Paris Act. So I'm a very strong believer in cooperation and mutual inspiration and sharing of knowledge. Also, I think the Corona period that we are still in, but hopefully on our way out of, has shown us the value of a close cooperation, the importance of a quick transition, and also keeping your suppliers very close. Of course, you can innovate with customers and with expert persons around the world, but it's just much more easy if you have them locally and you have them in your backyard. So we don't have unlimited resources, not humanly, not in financial way. So we want to take care of the ones we have in the best possible way, and to do things smarter tomorrow than we're doing them today. So I think that was it. I spent almost all my time.
I guess we could adjust the temperature here a little for the next event. It's getting rather warm and cozy. Well, my name is Lasse Ståhl. I'm the CEO of Adifab, the company hosting this great event to celebrate the fact that we have received enough help with this process to demonstrate that freeform injection molding is actually a sustainable alternative to conventional tool making, at least in the prototyping stage. I'm going to be walking you very, very quickly through the report that we have had developed by Deloitte and with Amhub as the funder. I'm going to tell you a little bit about the impact we expect this report to have. And then I'm happy to announce that we've actually received yet another presentation for today's event, which just means that I'll have to hurry up because we're going to be hearing a little bit about the case itself from the case company. So without further ado, Adifab is a company that was founded in 2014, December, by Jon Jessen, Peter Lund Sørensen, and I. Modest ambition was to try to see if we could bring 3D printing into the hearing aids industry, but we quickly found that injection molding and all the sexy materials available for that industry was a more interesting place for us to be. We have now grown to approximately 30 employees, housed in this great new building, and we have been diligently trying to make sure that systems from Adifab are installed across the globe, east to west, which is not very smart from a support perspective, but it does make sense from a global expansion perspective. And lately, we've also started collaborating with one of the most important players in the plastics industry, namely Mitsubishi Chemical, one of the most environmentally conscious companies, and one that plays a huge part in the creation of the company tomorrow, even to the extent that they've coined Kaiteki, the company of tomorrow, as one of their key statements. The challenge we're trying to resolve is that injection molding is a fantastic technology if you are Lego. If you need to produce millions and millions of identical parts, you'll never get to anything more efficient than injection molding. But if you're trying to develop a new product, you don't need millions and billions of components. You need only a couple in the beginning, growing to 10, growing to 20. Trying to figure out what the demand for a new product is can be brutally difficult. And some of the most successful Danish companies are actually pretty small suppliers, highly specialized in specific niches where they can defend a position because the market is small but lucrative. The design process for injection mold tooling is complex. It's time consuming, it's high cost. And what we find as one of the new companies in the field is that the conventional injection mold tooling, which is needed for injection molding, are simply over-designed. 3D printing has been proposed as an alternative to injection molding, and 3D printing is playing a huge and important role in the early stages of prototyping. But if you are an injection molder or a company relying on injection molded components for example for medical devices similar, 3D printing is not going to get you all the way into production. You will need to migrate to injection molding. So from a popular point of view, you can say that 3D printing is under-designed. It does not really deliver the quality, the range of materials, the productivity that is required to get to production. So what some of the other companies in the 3D printing industry have been trying, and what we're trying, is to bring the best from both industries together. We've got excellent materials from injection molding. We've got excellent flexibility, short lead times, low startup costs from 3D printing. If we could merge these value propositions, we would be standing with the perfect production technology. And the reason why we are relying on our unique approach with the soluble tooling is because we also need to get away from some of the limitations experienced with conventional printed tooling. For instance, you need to have a design freedom that is at least as good as with complex injection mold tooling, and you need to be able to access the entire range of injection moldable materials if you want to successfully supply to the injection mold industry. So we've decided to do away with an important principle of injection molding. Instead of being able to reuse cavities, we have decided that you can shoot only once. You dissolve your mold, and by approaching this philosophy from a constructive point of view, you get the opportunity of moving even beyond what is possible with conventional injection mold tooling, and you get access to the entire range of materials. That is a significant addition to the portfolio of injection mold tool making. What we are here to talk about today is the impact of being able to prototype injection mold tooling with 3D printers. We're going to be talking about the impact of not having to cut a metal tool to start injection molding. The curve we are seeing here is a very, very generic representation of what is going on when you start cutting a tool. You've got a CAD phase where you construct the component, you construct the tool. You may be 3D printing a couple of prototypes, and then you start using a lot of energy, a lot of materials to get to the first injection molding tool. For the case we've been looking at in this project, the figures are up there. Almost 100,000 DKK, which would be about 15,000 euro, almost 200 hours of work, and almost a quarter ton of CO2 was emitted in the manufacturing of tools for 4 injection molded parts. With freeform injection molding, the things look a little bit different. You can see the figures over there. They comprise a reduction of between 75% for greenhouse gas emissions and 85 to 88% for the cost and time. This is not something unique to freeform injection molding. We've seen that for other manufacturers of 3D printed tooling. But what is unique about our approach is that we can supply the entire range of injection moldable materials for the entire range of design complexities out there. Frank, you showed this one. I'm just going to focus on one specific item. That specific item is this arrow here and the similar arrow over there. Because what we're basically trying to do with freeform injection molding is to allow companies to not fail with metal tooling. We're trying to make sure that if you do product development, you should be able to do your learnings, your failures, with tooling that is not high cost, that is not made of metal, that does not have to be reworked in 2 or 4 or 8 week cycles. Because that is what allows you to reduce your cost of development. And I think, apart from this slide, this one is one of the most important that came out of this report. With the same budget, from a greenhouse gas emission point of view, from a cost and time point of view, you can actually get to do 3 times more innovation in a company. And circling back to what Thomas was saying, innovation is key, especially in a little economy like the Danish. We need to be able to innovate more, faster and cheaper than our competitors in order to succeed. So this, for me, is really the key point in the report that is found over there on the table and that is accessible on our webpage. The case company that was kind enough to supply the case we used for this life cycle analysis had 4 key findings. They found that the design freedom was top of the line. They found that cost savings were top of the line compared with the gold standard. They also found time savings to be top of the line. And last but not least, they found the sustainability profile to be one of the key issues in this particular project. They did not have to start cutting steel until they had to transfer from the prototyping to the production. And that's really what we're trying to bring about here at Adifab, that we don't have to start with over-designed tooling in the prototyping stage. You can find the report itself, as I mentioned, on the web page. You are more than welcome to access it also on the table over there. And I know that we will be talking a lot more about it in the months to come. And then as my final slide, I'd like to acknowledge the contributions from Amhub, of course. Without your funding, we wouldn't have been able to do this in the first place. Deloitte for doing all the heavy lifting with the mathematics, and Regionshospital Sjælland plus Krebs & Co. for actually having a case that was strong enough to be presented up here. And then I'm going to hand over the presentation. To Peter Bay.
And going forth and back, is that just up and down?
Yeah, det den du kører frem endnu.
Okay, great. So I'm Peter. I happen to be part of delivering this case. You can say the case came around because Sjællands Universitetshospital, they had this idea for this device that were to be developed, and fortunate enough, they knocked on our door and we got involved in it. And it happened to be that we worked heavily with AM hybrid freeform injection molding, and we used this as a tool to develop this device. And actually, the device is going to clinical trials, I think next week or so. So we are producing a lot of prototypes for that now. Some things to think about when you do clinical trials on humans. So there's a lot about how we make sure everything is on track and we have all the documents we need. A few things about my company and what we do. We are ISO 13485 certified. We're an old company, based or founded in 1956, but I've only been there for 5 years, so I haven't been along all the way. We do mainly injection molding. We do injection blow molding, 2K molded parts. We have from 25 tons machines, which is somewhat like the small ones you see in there, up to 900 tons machines. So that's as big as this room. And then we do a lot of AM hybrid with freeform injection molding, where we do a lot of different printing and molding in these prints. So one question that I've asked myself, and which is part of our strategy, can we be competitive and sustainable? And I think that's it's important. It has been a contribution finding out with this report that actually the way we develop is more sustainable. But generally speaking, what I've seen over the 5 years that I've been managing this company is that initially clients, they were not really looking for sustainable solutions, at least not the clients I spoke to. But over the last 2-3 years, I mean, it is becoming more and more of a theme. And now I would say it's unavoidable. If you do not have a take on how you become more sustainable in everything you do, then you have an issue. And as a globe, we will have an issue. And as I'm saying, it is a threat. So if I were running another company and I was doing my SWOT analysis, I would be seeing this as a threat if I did not have a take on sustainability, because I would be losing clients over time. I'm sure we are mature enough to work on it. We are not going to be successful in everything we do, but we will succeed. And even as a small SME company, we are only 25 employees. We also have an obligation to do this. It's part of our responsibility. Yes. Often when we talk about sustainability, we look at the final end products. And the first stuff you see up there, that's paper injection molded parts. It's actually interesting. It's a Japanese development. It's more than 25 years ago they started doing this. And they never really succeeded. And I think for 2 reasons. One is it is super complicated to make it work. Secondly, the market was just not mature enough, because who is looking for a biodegradable paper-based material? I mean, your shelf life is not really up to snuff. And in many cases, it is also a niche product because it is something that's going to degrade. So you need to find the products where you really, know that they will be lost somewhere outside. And And they are actually, you know, we have done these and they are truly biodegradable. I mean, they do disappear for sure. Same thing, you know, recycled materials. You know, we mentioned the O. Vestergaard Larsen and the projects that the Danish Plastics Federation are doing with them. We are also in a project with the O. Vestergaard Larsen where we are looking at 100% recycled and food-approved materials. So that's going to be super interesting over the next 3 years to be successful with that. But also we are doing other things with them. So this is an old picture of that box, but that box has actually been redesigned now. It's for home deliveries of food. The next version that's coming out is going to be in reused plastic. So it comes from cheese boxes to carry cheese around. And now it's going to be brought, you know, home to families that are ordering their meals online. And it's made so that once it reaches its end of life, we can actually recycle it once again. We can take the entire box, whereas that version could not be recycled because that would need to be taken into parts and actually not really easily recyclable materials. So that's another one, but that's only the end product because as we spoke about, you know, it's the whole development that is that's bringing about some of these emissions that we are talking about. And with, you know, with AM hybrid, we're doing a lot of things. So, you know, it's all about reducing the time from idea to promotion. It works really well. We are, as Lasse was saying, you know, fail fast at a reduced cost, not only financially, but also environmentally. And that's what we have seen. I mean, when we talk about this case that we have had, you know, if we had been cutting steel from the first iteration, I think I would have had at least 20 tools on my shelf, which I could have scrapped by now. At least. It's also increasing our innovative playing field through geometrical freedom. I would also add, you know, we are always thinking about how we're going to mass produce this afterwards. But again, the ability to do things with additive manufacturing makes it possible for us to be very creative. You know, we are not constrained by, you know, what can our milling machine do, what can we do, because the printer really does most of it for us. Of course, we are building on the strengths of conventional technologies. You know, we are using injection molding. We're using all the materials that we have in injection molding. And then, as said already, you know, this thing about reduced environmental impact. And then an example of what we have done. So this is part of that product. I'm not ready to show the entire product yet because there are some patents and stuff around that. However, it's consisting of a plunger and a sort of long device to hold this plunger. And it's 2-component molding for the plunger. So you can see the blue part is basically the plunger, and then there's a sealing, which is a TPE material, and there are actually 2 of those on this plunger. And what we saw in the trials was that, or when we started doing this, was that for the user, both the dimensions on this are critical because as it is a plunger, you need to have the touch and feel. How does it work when you push it forth and back? And secondly, you are not only pushing forth and back, but you also have to rotate it. So there's also that you can actually be able to rotate it without having issues. And there's a third thing, because when you use it on a person, you have something around air that needs to get out, but you don't want the substances in there to get out. So we also worked with different designs on this part so that we actually have it sealing against whatever is physically in there. However, we want to be allowing air to get out at the same time. So that is also a little bit critical. But all of that was things that we could do, as I'm saying over there, you know, molded within 24 to 48 hours, doing different designs, changing iterations. And I happen to be the first person actually to trial these, and they work really well. I did it before we were allowed to do the clinical trials. But they work well. And as I'm saying, you know, more than 10 designs in 2 weeks at a cost of less than 50,000 kroner. I think it would be hard for most companies to say that they've done 10 different designs in 2 weeks at for 50,000 kroner. That's virtually impossible, unconventional. So, yeah, then we do some other thing. I mean, we do a lot with this AM hybrid. So you can see on the left there, I mean, really, really simple stuff. Direct 3D printed. We don't always have to go all the way and do hybrid and all of this. Sometimes we do that. Then this is a case for some dental work, which came from initially doing stuff like that, and then we moved on to a mix of AM materials and metal, and we ended up with a full metal one, so we could do 200 parts for clinical trials, and that's actually this is part of it for the final metal version. So yeah, and then some other stuff. This is a cup for old people. They forget to drink, so it's kind of an intelligent cup. It sort of measures real time that you are drinking enough water. I mean, you don't really think about it, but apparently it is a big issue. And when we think about, sort of health and public service and all of this, the issue is that if we have to have people running around checking that older people are drinking enough, we are not going to be enough, Danes around to make that happen over time. So intelligence, adding intelligence to cups and glasses so that we can actually monitor and see, it's Gerda. We need to go and check on Gerda because she's not drinking enough. It makes, all our SOSU and whatever, it makes their life a lot easier. And I think that's going to be the solution for our, to make sure that we have the society we want in the future as well. We have already seen some of the data just illustrated differently on what this means in terms of impact, more visually appealing. So we go for the yellow one, less. Just to sort of, AM hybrid, it's not a one-stop shop. I think Lasse has already mentioned it. It's not going to solve all the issues we have in the world, but it's a really good tool in the toolbox. It brings us from idea to promotion at a reduced cost, at a reduced environmental impact. And as I think a lot of people have said today, we have only just seen the beginning. I think I was the first one to buy one of your machines. Believe me, we have made a lot of mistakes, but we are getting a lot better fast. The curve has been very steep, but there's still much more ground to overtake. So thanks a lot. If there are any questions, then we can take them. Otherwise, there's going to be a panel debate later, right?
Exactly. Yeah.
Great.
So, Martin, you get time to take over this?
Yes. Thank you. Thank you very much. Is that my slide?
I think it is. It does look like your slide.
All right. Okay.
The design has changed a bit.
The design has changed, I would say. So, all right. Let me see how that works. Okay. A little bit about myself. My name is Martin Friis Mikkelsen. I'm the CEO of Saxocon. I'm an expert within regulatory processes and within medical devices. These are some of the guidelines that we're using. And I'm going to talk a little bit how can we accelerate the development phase of a medical device. Some of the key assumptions here. Adifab has accelerated the design, the device design, and now it's starting to create some. They can create some clinical trial ready final devices that is needed for these clinical trials, and that's important. And I can tell you a little bit about that a little bit later. But they have also done it in a way that hasn't been possible before. We talked about 3D printed things that you use into a medical device. Well, that is a little bit difficult. It's more difficult. Now we can actually go in and do 3D, the actual device in the right material to use in the clinical trial. That's important. So the whole thing about this is also that it's this accelerated design process is putting a massive pressure on the regulatory approval of the devices, and especially the biological safety of the products could be a bottleneck. So I'm gonna talk a little bit about that. And basically,
this is what I'm gonna focus very much on. Some prerequisites, crucial prerequisites for a clinical trial, is that it's conducted as a final finished product. It's the product that you're going to sell, that you're going to market it in the world. That's the product you need to go in your clinical trial. And also, it needs to be safe, basically. So some of the biggest headaches that we have here is that many times the materials and the suppliers are frequently ejected. And some of these failures of not selecting the right materials is actually going to give you some issues downstream. Give you have to do redesigns, you have to do a lot of other not very good decisions, and it's going to take some more time. It is very costly to do and redesign later on in the process. And especially the whole documentation afterwards of if the product is safe is something that's going to take much longer and very costly if you have to redesign the things. I'm going to come in a little bit later on that. So could it be otherwise? Yes, but there needs to be a paradigm shift in the device development that we need to go in and put into place. Basically, it's all about addressing materials and suppliers when you actually are going into the design phase. You need to go when you define your case, your device. In order to de-risk it, you need to make sure that the key materials, the process that you're going to use for producing this will have to take. You need to really be careful and take the right decision there. So you need to kind of this will also give you a way to go in and make sure that you can use materials that you haven't been using before. Sometimes you stick to the same materials. Here you can actually go in and use a variety of materials. It just needs to be well characterized. It doesn't have to be used before, but it needs to be well characterized. And that's something that the designers, the developers need to take that into account. So how can we accelerate this? So we all know that there's the regulatory landscape is changing. I can see that we talked about here in May here, the MDR was just announced a year later than it should have been. But one of the things is that the materials that you previously could use is probably now not even close to be able to be used now because of the new regulation. So and some of these things that needs to happen within this paradigm shift here is that the material safety needs to be part of the design process. It needs to be on par with all the other criteria that you pick materials with. Medical grade is not an insurance for no problem, not at least, because there's so much other details around the materials that is needed. Biological evaluation of the device need to actually start already in the concept phase. You can't start it later on, and I would say 9 out of 10 projects is like that at the moment. So the biological evaluation needs to be planned and carried out by people that knows about this. It's not something that I'm an engineer myself, so it's not something that an engineer can go and do. You need to have some special skills in order to do that. And the thing is that is some of the new things under the MDR. You need to put your CV together with the report that you write, so the authorities can see that you are actually knowledgeable and experienced in that sense. So I will illustrate this by using this classical V model that a lot of developers is using. We have a concept phase where we put in the requirements. We have a preliminary design phase, do the design, critical design phase, the prototypes is starting to come out. And with Adifab's new technology here, we can actually do prototyping that can go directly into a clinical trial. That's the new thing. And then you have, of course, you need to verify that these products is all right and follow the specs. And again, the validation is the requirement. Are we following all the requirements, and does the product works well? So the V model today is, when you talk to a biological safety context, is that you get with the acceptance test, you have the authorities will come back and say, well, yes, you're approved, you get your FDA approval or CE mark. Before that, you have to, with the system test and acceptance test, there's also the clinical trial. So before you have actually go to a clinical trial, you have to have a biological evaluation report that verifies that the product is safe. That's a key thing. How can you do that? Well, many times you have to do some testing, and you have to test on the prototypes. And today, 9 out of 10 products is focusing very much on that part, on the right side of this V model. But we need to change that. So basically, already in the requirement phase, you have to go in and look for information on the materials and pick the right suppliers. That's important. You also need to do a pre-assessment of the materials. Does this material, can it be used for my device? And the biological evaluation plan needs to happen before you actually start developing your product. And again, the biological evaluation plan gives you the design input so that the developers can actually design the product that is biological safe. So what we are doing is that we need to switch this from the right side and the focus over to here when you talk about biological safety. So deep knowledge about materials and interaction between materials and things like that is where we can see that there's the full formulation of materials is something that's difficult to get, but it's something that is needed. It's something that the authorities require, and it's something the authorities are looking at. So we need to make sure that this has been looked at and evaluated. And you need to work with the suppliers that are capable and are willing to give this and share these materials information, and not only sharing the minimum information as an MSDS, because this is for work environment. This is not for biological safety. So you can't really go that way. So, and again, the knowledge of the material needs to be gathered as early as possible in the whole process. And the concept phase is actually there where you can start the work, but it has to be prior to design phase. And again, what we have here, and that's why I have put on these servers here, we have a large database where we can actually come with, where we have an extensive knowledge of all the material processing aids that is normally used in the industry. And we can guide our clients in order to pick the right materials and pick the right manufacturing processes in order to make a safe product in the market. And again, the pre-assessment of the materials is something that's also very key. Some materials are not suitable for medical devices, although it's still being used. And under MDD, well, that was not a problem because you can, the regulatory authorities will not go in and look at it. They were just saying, okay, is it medical grade? That's fine, we'll go for that. That has changed a lot. FDA is starting to go the same way now and has done that for many years. So you need to make sure that your material is suitable for a medical device. So a pre-assessment has to be done early in the design phase, and it has to show that it can be used for a medical device. Again, the pre-assessment also needs to be conducted by somebody that knows about it. Needs to be with the right CV, and this is your insurance that you don't get any late surprises that we have seen many of. And again, the material needs to be under quality control. And the worst case scenario is that you come up and you fail the test, You have to go and redesign it, and then you're back in there. It's going to take a lot of time, take a lot of money, and then you have all the things that you have saved on using the free-form molding. Well, that's gone, basically. So a little bit about the biological evaluation plan. Well, this is something that, besides it's mandatory part of the regulation, and being part of the design and risk management plan, it's also a valuable tool that you guys can use in order to make sure that the design is being made very well, and it's going to be giving you the design inputs to the development team. So the biological evaluation plan will identify gaps that needs to be tested, what type of material is used, how it's going to be manufactured, what is the intended use of this device, and all this needs to be listed up in the biological evaluation plan. And the only thing that's actually mandatory for testing, according to the guidelines, is actually chemical testing, not biological testing or anything like that. That needs to be argued every time. But depending on the intended use of the device, some biological tests will be needed. But again, it needs to be planned well by knowledgeable people. And again, the materials and impurities from manufacturing process is primary reason for many of these verification tests that fails. So it comes out that some of these tests will not pass what we were actually expected. So some of the key takeaways from here is biological safety needs to be part of the whole design control and going to be paired with other material features. It also, you need to assess the material as soon as possible, make sure that you start gathering information and make sure that it's suitable for your device. And again, make sure that you have the people with the right knowledge and experience on board to do the job. If you don't have it internally, go out doing experts. Don't do as many people have done in the past to think I'm an engineer, I can do it myself. Well, it's not that easy. I can trust me. And again, the best way actually to accelerate medical device development is to take the important decisions in a timely manner and prior to the design freeze. That must be, I think, the best takeaway that you have today. I think that's it. Thank you.
Yes. Okay. Welcome back, everyone. We now have almost half an hour for a bit of a panel debate. On this panel, I have here Peter Bay from Krabs & Co., who also just presented, Martin from Saxocon, who also just presented, and Mads from Erhvervshus Sjælland, that just arrived here also and will share his thoughts in our panel. So thank you very much for that and for joining. So the theme of the panel is sustainable development, and that is a really, really tricky thing. It's a really broad term, and I've just thought a bit about how can we discuss this in a bit more tangible way. So I think first of all we should maybe split the two words and just start by talking a bit about sustainability in itself. I can start also just risking my own opinion and views on that. And you can follow or challenge me if you like to. And then I think we should move on and talk a bit about innovation, talk a bit about what is there like a key Danish ingredient or key Danish core innovation muscle, and what is it, and how do we strengthen it, and how do we ensure that Denmark plays, I think, the ambitious green nation role that we all want it to be in the future. So circling back to sustainability, this slide that I presented in my presentation is from Bill Gates' book, How to Avoid a Climate Disaster. And there are many ways to show these numbers and to divide them into different sectors. I like this one because it's really, really, really simple. And if we look at the slide, it's also kind of a maybe a bit of a kick to Danes, because usually when we in Denmark talk about sustainability, we talk about windmills, that's for sure, wind farms, lots of them, big wind farms, and we talk about electric cars. But we also need to talk about chairs, we need to talk about cups, bottles, houses, streets, everything else really that we produce and where that comes from. Bill Gates, he actually calls that sector the most tricky one, the one that worries him the most, because on the other, we have really good alternatives. The problem is that development countries right now, they will look at how do we develop in a good way. And they are looking at China and thinking that is the way we will develop. So if you look at the numbers up there, they will increase with a factor 2 or 4 by 2050. And remembering the point made by Thomas also, you know, we need to do stuff today. And that is just taking us kind of the wrong way. So the challenge within sustainability is clear. We need to do something right now. How we do it is much more difficult, I think. So we in Danish Amhub has pretty much changed everything in our strategy to see additive manufacturing as what it is. It's not a mission in itself, because no one in the world will be better off if we just print everything. It is a tool that we can use for a mission, and that mission is to create a more sustainable production system. And we are really, you know, we're focusing on the technologies that do that. Also, really being humble and understanding that that is really difficult. There are a lack of data, there is a lack of documentation, and we need to work in that direction. But if I'm rambling here around sustainable manufacturing and about the things that worry me. Do you recognize that, or is it? How do you see that, Peter?
You know, being an owner of a manufacturing company, I kind of like to produce things.
Yeah.
It's kind of how I make my living. Obviously, there's a big benefit. It's always, having your own company, you of course have to think about liquidity and all of these things. So you don't have, all the investment power that you would want sometimes in order to invest in things which are more green. But one of the things that I do see, and which I experience quite often, and especially when we talk about the additive manufacturing sort of shift that we're seeing, is that companies, they can at an earlier stage test their products to avoid taking it to the market if it's the wrong thing. It's kind of this thing, avoiding to do things that where you take it too far and try to sell stuff which really shouldn't go to the market. Because as soon as you've made a big investment in a tool, then you're kind of forced to take it, one step further and try and, promote it. At the end, you're promoting it at a discount, and then, everybody gets attracted by discounts, right? So obviously somebody buys it, and then at the end of the day, we have this sort of a negative spiral. So you can say, the first thing we can do is to try to think about avoidance. Avoid to do the things that are not needed. Avoid to produce things which are not needed. I think who was bringing this thing about Ledbeck Plast, this thing about the windows, the frames, and how we can take those things apart. I think that's also a great example of producing something where you are avoiding some of the negative side effects that you will have later on in life. But I think step number one is to avoid the things that we really don't need. Any thoughts on that?
Well, if I take it back to my backyard, is that what we do is that we're going to reuse, and as a consultancy company, we reuse a lot of data, and what we avoid is to do a lot of animal testing. So this is a little bit a political correct way to do this, but the thing is that it's again, if we reuse data and we avoid to do a lot of expensive animal testing on animals we just kill and then throw away, This is what we believe is sustainability in the way that we in our world. And again, we avoid if this product is not going to come to the market. Well, we haven't wasted a lot of lives, animals' lives in that sense. So I think that's the way that we see sustainability: reuse, also reusing products, but also reusing data instead of just go and get new data that already are there.
Thank you. I'm not sure whether I'm a big expert on sustainability, but I'll at least try a little bit because I think it's a really interesting topic, and basically I'm very optimistic about the whole sustainable agenda because if I look at startups and I look at small and medium-sized enterprises in Denmark, you see nearly all of them have some sort of focus on sustainability. So their mindset is set on how can we reuse things, how can we be using less energy, how can we produce renewable energy, etc., etc. So there's a great wave of innovation and inspiration and development among startups and SMEs and also larger companies. So I'm actually pretty optimistic about this. The only thing where I'm a little bit pessimistic is that I see a really strong commitment among the small companies and the startups, but I see far less commitment from the public sector. So it's very much, as I see it, it's very much on the really big agendas. So they look at the 70% reduction in CO2, but they're not doing anything. So I think that's one of the really big topics is that you have not transformed the vision and the goals to concrete initiatives that you could use. And I had a presentation a few days back, and one of the other guys that did a presentation, he was in the plastic industry, and he said that he had some good news about plastic. One thing, he had a good news about plastic and bad news about plastic. And he said, first of all, you can use plastic for almost everything. So you can produce almost anything with plastic. So that was the good news. The bad news is that the whole world is doing that. And therefore you have to think about how can you reuse, how can you recycle, how can you do it in a more sustainable way. And he's right now recycling glass fiber from windmills, and selling it to the automobile industry in Germany. So that's one way of doing it. So, but in general, I'm really optimistic, and when I have the positive climate agenda, because when I look at some of the solutions out there, I think that it's not solutions that we'll need. It's more action from primarily government. So I'm basically optimistic.
Good to hear, and thank you for that. I will not let you off the hook right now within this with this theme. I'm often challenged with when additive manufacturing will start producing millions of parts, and I often challenge that back and say, why would we? Because it's a new focus. I think the last 5 or 10 years really that manufacturing has to change. So I really share your vision also, Peter, that the best product is the one that we don't have to produce, which is a bit weird saying, but it's actually true, right? And it's difficult because the planet doesn't care about Denmark, really. It doesn't care about borders and 70% and all of the government initiatives that we have in our small country. The planet wants us to figure out solutions so we don't produce in an unsustainable manner. And right now we really need those solutions. And there has been fantastic examples put forward today, so I won't dive into that detail right now. I'll just ask you, circling back to your point also, Mads, around the government side, if you could give one piece of advice to Mette Frederiksen, and I know she listens to advice very, very good. She's a very good listener. So if you have one piece of advice around how to create a more sustainable manufacturing site, what would it be? Only one, yeah. The killer piece of advice that you would want to deliver to her, so that we ensure that production is done in a more sustainable way. It's a really difficult question, so I'm just giving them a bit of time to think. I think there's a lot of different takes you can have on it, because it's the whole talent idea, putting powers into production, putting investment into production, or whatever. There are 1,000 things. But yeah, I don't know if any one of you would like to start that advice. Yes, Mads?
I like to start because I think it's pretty simple. You have to make the right incentives for companies to react, and we've seen that works. I mean, almost every time you've done that in Denmark. So when you did the incentives for the windmill industry, suddenly you had a windmill industry in Denmark, and that cost at that time it was really, really expensive. But today the cheapest way of producing energy is land-based windmills. So right now it's actually on market terms the best way of producing energy. So incentives is basically the word, and we've seen it when you gave incentives to the biogas industry. You saw a lot of biogas plants coming up in Denmark. You can see it when you did it with solar panels. A bit too good incentives, I would say, because you saw an explosion in the use of solar panels. So it's basically to get the right incentives and be able to adjust them and have the long-term view on using the incentives. A lot of Danish core industry is based on incentives. You have the windmill industry, you have the hearing aids, you have the wastewater treatment plants, and the water treatment plants in Denmark, all based on incentives from government. So I think that if you want to solve the climate crisis, then you have to look at how can you give the right incentives, and that also works for the manufacturing industry to give incentives in reusing plastic or doing other things in the production at the production sites. Then you will see a lot of action.
I fully buy the idea about incentives. I mean, we are trying everything we can to there are sort of programs out there by the government, funded by the government, which we are applying to and which we are getting, and where we're trying to both reuse material, recycle, whatever. But I also think, the case that I showed earlier today is interesting. And I think from a government point of view and also from a legal point of view, between me and the government, or me and the sort of hospital, we haven't come to the right solution yet. But the idea is quite good, because what this little device that we are producing or have developed together with a doctor and an inventor and a nurse is actually taking a lot of hours out of hospitals, in terms of hours that nurses would need to go and check on patients, where we could diagnose patients a lot quicker. And that's, from an environmental point of view, a big burden to take away, because this little device that we are looking at is typically cutting, a 3-day isolation room into half a day. And if you know how an isolation room in hospital works, then nurses go in there, they put on, all sorts of cover, masks, whatever, and go in and check on the patient, go out again, throw it all out. That's plastic straight to the waste bin. And on top of that, of course, the cost of running that sort of isolation room. So I think more cases like that would benefit the environment significantly. And they are trying, the hospitals, the government, they are trying to make programs like this. How do you incentivize? Because it is a tricky one. You need to have somebody come up with the innovative ideas, and in this case, it was the combination of a crazy inventor, I would almost call him Anders, the nurse and a doctor. And somehow they came up with this idea to say, we can actually tackle this problem. But you kind of need to have the forum where you get these people together. And then on top of that, you added, some crazy people out from Skaving, where I'm based, and we sort of made it something that you could produce. So it's making that happen and making it happen often. Then we can actually, innovate in a sustainable way and take out emissions in that way. And for me, it's incentives because it's potential business when we are successful.
I think that's
Yeah, Mads.
Just to give an example on the incentives in the guy with the plastic and that you can produce everything in plastic. He said that for them, the market moved right at the time where they were saying to the glass fiber users that they should pay for landfill. When they increased the price there, suddenly it was a good idea to recycle because then you could sell it at the right price in the market space. So it's quite simple, and it's a cost on society. So if you take your glass fiber from the windmill industry and you put it in a landfill, that's a cost for society. So of course that should be priced. And if you do that, then you can share, the producer of the recycled material can share the cost or share the profits with the user of the glass fiber. So I think it's basically quite simple. It's just to go out and do something.
Yeah, no, I share that. We have a lot of engagements and work with clever Danish startups, and I almost think that it's such a giant they are up against always if they want to change production and create a more circular system and use waste as their input to their production so that their finalized products, etc., etc. It's such a difficult struggle because everything we've done with production has circled around cost and synergies. So the last 100 years, we have built production systems that are so great in volume and so efficient. And I can sit here and order something and it will arrive from China in 2 days. It's really, it's almost, crazy. It's really kind of an achievement for the human beings that we have, managed that. But we need to change that for sure, because it's just as, cheap it is, just as costly it is for our planet. So we need to really reconfigure that. And also circling back to fossil fuels that is used to drive much of that production system. It's almost an unfair game because it has more firepower than a hand grenade, and it's cheaper than a glass of orange juice. It's really it's crazy. So if we want to go up against that system, I think we need a bit of muscle and a bit of incentives within that field and systems. But we talked a bit also, Peter, you said with those clever cross expertise, so the nurse and the entrepreneur and the technical guy and the finance guy, etc., coming together in one room and working with innovation. And I'd just like to ask you, Martin, also from the things that you've seen within the medical field, which has a rumor of being really heavy in terms of process and in terms of regulation, and it has to be because we all want to be safe and keep everything in order. But do you see any solutions in terms of bringing that innovation to the forefront more easily? Is there anything we could do in Denmark to ensure that the clever guys out there, for instance in Skaving, could put their products to the marketplace faster?
I think one of the biggest issues we have here is actually all the mistakes that is made during the development. We've seen a lot of things happening. Let's say they invented this very nice product, put it almost into production, and suddenly it doesn't get the right regulatory approval. Then you have to scrap it all. So it's very expensive. So the whole thing about fail early or fail cheap is one of the things that could change the things. That's also why we talk about making sure that you all do the due diligence in the early stage. Then you can set the things up for success. But also look at the requirements. Is there a need for this? Because many times we have seen a lot of people that has put a lot of money into an idea, but suddenly when you look into the business case, there's no idea, or suddenly there's something else that comes up that changed the whole agenda for this idea. So I think it's all about making sure that you test out your ideas very early, and then again, Adifab's Freeform Molding will help out this to make sure that you actually are coming up with nice prototypes, making sure that you test it out. But again, when it comes to the regulatory part, when it comes to medical devices or even combination products, well, it's not that simple. So that's why you need to be careful that you take the right decisions very early in the process. And that's where I think we have seen too many that fail very late in the process, and then it's very expensive.
Yes.
Sorry, I had promised myself to keep quiet, but yeah. You mentioned something en passant in your presentation, Peter, that I found to be extremely interesting. You were talking about food-grade recycled materials. And I think one of the key things we need to address here from a systemic point of view is the lack of standards, is the lack of solid data. We've tried to produce some data here about a specific manufacturing process. It has a sustainability profile, super cool. But if you want to move recycled material into the industry of food processing, I mean, that's something that'll require an entirely different level of knowledge. And I think if you look at the barriers facing what we're trying to do here, having a standardized system, having a standardized approach, like what you're proposing, Martin, that's really going to be one of the most important things we need to address in Denmark. We need to address on a global scale. Because as long as we're just talking about sustainability without being specific about how to measure it, we wind up in a tough spot. And I think reusing data like you're suggesting, putting up the systems that allow us to characterize materials in a good, consistent way, that ought to count for something.
Yeah, for sure, Peter. I don't know if you have any supporting points.
I mean, just to say a few things on that. It is a super difficult project because it's initially we're looking at industrial recycling, but we're taking it all the way to post-consumer recycled materials. And of course, the whole process change to clean and do sniffing and whatever you do to sort of take out whatever is not clean, it's quite advanced machinery that needs to be set up. And there's a complete building set aside up in Mariager right now, which is going to house that machinery or set of machines. So it is super interesting, but it is a tricky one. But you're absolutely right. I mean, that's where we want to go to, because it's difficult to always have these closed loop. I mean, I mentioned these cheese boxes, right, or cheese baskets, right? I mean, that's quite fortunate because they just happen to come ever so often. I mean, that's just a steady flow of cheese boxes that needs to be recycled. So I just have a nice stream of cheese boxes that I can use for these cases, right? And later on I can throw a few of my own boxes into it, right? And then it works really nicely. So, but we are not always in that situation. Often, it's a bag of mixed materials, and then you need to figure out what is what. So that's tricky. Yeah. So.
Yes, I don't know if you have any questions out there. Just let me know, and I'll bring them to the panel. I think we have about 5 minutes left. So we've given the Prime Minister a bit of advice, and we've talked a little bit about innovation. There is one key ingredient within innovation, which is not, the human side and the culture side, which is new technology. And, I'm really into that because additive manufacturing is a rather new technology. and there's a lot of frustration within that field. There's a lot of hopes, a lot of also, I thought it could that, but it doesn't do this. So I'm in a bit of problem, and now I never use it again, specifically in Jylland, where a lot of the manufacturing system is. So how do we put in place new technology on Danish soil? What is it that we need to do? What kind of, also in Erhvervshuset, for instance, Mads, how do you work with your companies in Zealand on, take these chances? Because every time you do stuff, it's more resources, it's more investments, it's more frustration, it's more work. So how do we ensure that they, try these first experiments so they'll see that, okay, there's something about this, and now I'll carry through with the large investment? Peter, you?
Yeah, I mean, if I sort of think back on some of the cases that we have worked on, and we have a case which is about to kick off, it's been on projects where there's a big upside for the companies involved. This is with a Danish medtech company, it's with a Danish tool maker, and it's with us. And it's basically, we have had long-standing sort of talks, not negotiations, but talks with this medtech company, and they have actually forced us and the tool maker together. We are both great in each our area, and historically we would never cooperate. I mean, I would probably like to cooperate with him, but I don't think he wants to cooperate with me. But nevertheless, now we are being forced to do it because we have a mutual interest in the same client, and I think that's fantastic. But the driver behind this is that the benefit for the medtech company is significant. They have a lot of upside if this project works. Then they can develop these medtech products that they produce much faster, cheaper, better in the future. And they can do it in the right materials, and they can, test it and see that it really works and all of this. And they want to do it in this way because they have historically had to do it in a very costly way, with steel tools and all of this, and often made it very, very difficult. So now I think this is going to be really interesting because now we're combining, highly advanced injection molding tooling with additive manufacturing, small inserts, and very complex geometries where I would say even for a metal tool, it's almost impossible. So it's super complicated. And you can say, then if we can do it really clever and so on, then hopefully it could also be production that we take back to Denmark or Europe at least, where we don't ship it all to Asia, because it ends up being sort of almost handmade as it is now. So.
Yeah, thank you. Any points on that? Or else there is a question, I think.
Yeah, so someone online asked earlier on, someone asked the same products that will years time, how can you extend the lifespan of essentially a work?
Yeah, it's a tricky question. It's a difficult question. Yes, I will repeat it. So how can we produce products that we can re-engineer, we can remanufacture them, we can without putting them on the landfill? Is that correct? So the question was that often the waste is like products can only be there for 2 years, and then there's a lot of waste. So how can we change that? And we have been circling around the circular production system and moving waste into the production system. I think one thing that inspired me here the last week was from the German manufacturing of cars in the big conference they have in Munich, EAA, which is, you should check that out because it's really showing you kind of where manufacturing is moving. There is a new car from a BMW coming out that's called iVision Circular, and the product in itself, so the car here, is 100% circular. and it will first be there in 2040. But BMW has put that car out there and said that is our plan. So 100% circular. The board they have inside the car has a 3D printed crystal also. So it's really something to look at. There's also the new electric car called Audi Q4, which is on the streets right now. They have really looked at first, how do we produce that with green energy? So in the factory in Zwickau in Germany, there's a lot of wind farms and green energy. And what they cannot produce with green energy, they've offset with forest projects and others. So they're sure that a car is 100% CO2 neutral. And there's a lot of discussions on that. I don't want to open that up. Also, the seats are made from reused plastic bottles. So there's a lot of great stuff out there, and this is the car manufacturing industry, which is kind of conservative, let's be honest. But we have in Denmark 400 suppliers to the German car industry. So I'm thinking that, looking at some of these producers would give you a picture of where is manufacturing heading on that. And then circling back to Mass's point around incentives, if we would put a price to waste, for instance, and just say, the waste stream in itself has a value, that would just, create a massive, I think, flow of new ideas and new business models. And I think, somewhere around the line that will enter. I'm not sure when, I'm not sure how, I'm not sure where, but we cannot generate as much unused waste as we are on the planet, that's for sure. So I don't know if you have any supporting or challenging points on that. Yeah, you cannot. You have to.
But it's always a little bit tricky. If I understood the question right, it was about this thing that you have a product, but within 2 years it's becomes faulty kind of. I think it comes back to Martin. Finding the right materials, producing it the right way, making sure that you have the right processing techniques around so that you actually produce something that's long lasting. Then of course there are things which from a design perspective kind of just become so last season.
Yeah.
That's always going to be tricky. I'm not the one to guide on that one.
No.
My kids say I'm so last century. So so anyway, but I think there's something around that that we design for recycling, we design for reuse, and we make sure that we use the intended materials in the right way.
Yeah. Yeah. So my favorite example is the Happy Meal toy, which is crazy because if you've ever been at McDonald's. And I know a lot of you have been there. we buy that Happy Meal because our kids have fun for like 30 seconds, and then it's gone to the dumpster. And I think that just has to stop. Really, there's a bit of something we can change with innovation, but something is also just a behavior thing. So we need to stop that right away. Yeah, and then on the more circular production system, and I just gave the examples from the car manufacturing industry. There are a lot of really cool Danish examples, and when I mention one, there's 1,000 I forget, but I just like to maybe point you to the new loudspeaker of BO Bang & Olufsen, because it is made for fixing. Which is, thank you for that. Finally, I have an age where I used to fix the radios at home together with my father. So I don't know if anyone remembers that. Yeah, there's a bit of smile in here. That's like the greatest thing ever. And I think we're heading back to that again. And Bang & Olufsen has made a loudspeaker where you can change, for instance, when the battery is obsolete. The battery system won't work anymore. You can, just take it out really easily and put a new one in. Boom. Thank you very much. So there's, a lot to do within that field to make sure that we don't have, 30 seconds or 2-hour products that are obsolete with, just the blink of an eye. So, a question?
Frank, early on you mentioned that this could be the new Lego, basically, for Denmark. So I'm curious, if we look 10 years ahead, what would be our value proposition for the world? Like, will we be a manufacturer? Will we be working with innovation? Will we be designers? Will we be doing legislation when we kind of re-export this to the world? Like Vestas is a major player in the windmill industry. We know they're exporting to the world. What will be the export, the Danish value proposition in this field?
Yeah, so I'll try to answer that. Do let me know if you have inputs also in the panel, but I don't want to pinpoint to a specific sector, because we have a lot of them in Denmark. I'd just like to mention an overlooked, I think, fact is that in Denmark we have a lot of green energy, and it doesn't make sense to use that energy to make black stuff, right? So, for instance, Facebook and Apple and Google are very interested in data centers, in building out data centers in Denmark, because we have a lot of secure green energy. Now, in newspapers today, you'll see that maybe that is not, the best idea for Denmark, because there's not a lot of employment within these data centers. It takes up a lot of our, Jylland ground, which is fantastic, and also it will, cost us taxpayers a little bit to have Apple with a data center in Jylland, so it's a bit tricky. But what if, we could be the production hub of the future that would create, design, develop, and produce the green products of the future? What if, Autodesk, EOS, BMW would look to Denmark and say, hey, let's put a center here. Let's put a production facility in Viborg or in Aabenraa or wherever to work with the clever Danes and use their green energy to produce the products of the future. That is kind of the vision that I'm trying to, it's a bit like the movie Inception. I'm trying to, give people an idea, and then suddenly it's their own idea. So I really would like to share that, because only if we think that is possible, we will start working on it and make it happen. Mads?
Yeah, I think that it's a really, really good question, and I don't think there's really a good answer to that. But I think if you observe the startup industry and you observe the small companies and what they do, then you'll also you get optimistic, because you can see that there are a lot of ideas out there and a lot of things that you say, is that really produced, or is that a product that is actually used? And I have this perfect example of for in a small municipality in Region Zealand. Also, there's a company that produces the opener to the greenhouses, not the large greenhouses, the one that's in your backyard, and that's the only thing they do. And they have invented a certain wax that will open the window when it's too hot and close it when it's cold. That's genius, but I mean, and then it's produced in a small factory in Odense, and I think that's an example of the creativity and the good ideas in Denmark. And you can't really predict where will the next big thing come from. And I think that's what is often misunderstood when you say it's only tech, or it's only food, or it's only life science. Then you have already narrowed the spectrum too much down. You have to look at all the good ideas and then see if the ones that are really developing at a fast pace, then give them some more fuel, and then you'll see a great future for Denmark and the world.
Yes, I think that was a brilliant ending to the panel debate. Thank you for joining and participating. Thank you all here today, and thank you to Lasse and Adifab for hosting this and putting this forward on this important point on the agenda. Thank you very much. Thank you.